Hello, students, and welcome to our lesson on percentages. So we're just going to dive right into it with what is a percent? The word percent translates literally to the phrase out of 100. So when we say one thing is a percent of another, we are saying that it is that number over 100. Therefore, 38% is equivalent to 38 over 100. So when we say percent at the end of a number, we really mean that number divided by 100. A percent just tends to be an easier way to describe it because we use percents a lot in mathematics. And so instead of having to say 6 out of 100 or 7 out of 100, it's a lot easier to just say 6% or 7%. And it makes our calculations look nicer when at the end, instead of having all these decimals or fractions, we just have nice whole numbers. All right, since percentages can be written as fractions, that means that they can also be written as decimals because fractions can be written as decimals. So we need to be able to convert from one form to another form. So we have steps to convert in every direction. If we want to convert fractions to decimals, we are just going to simply divide the numerator by the denominator. So for example, if we wanted to convert 1/2 into a decimal, we would just divide. 1 divided by 2 would give us 0.5. No big deal there. If we want to convert decimals to percentages, we multiply that decimal by 100, which is equivalent to moving the decimal point 2 places to the right. Okay, so for example, if we want to turn 0.5 into a percent, this is equivalent to, if I move that decimal 2 spots to the right, I have to add an extra 0 there, so I would get 50%. Where when I move that decimal, because there's only one digit, I have to add a 0 to move it to that second spot to the right. But all you do to turn a decimal into a percent is multiply by 100 or move the decimal place 2 spots to the right. If we want to convert fractions to percentages, what we can do is convert to a decimal and then multiply by 100. So the easiest way to turn, this one is probably the hardest one to remember, even though it's the easiest. If you want to turn fractions into percentages, we don't generally go straight from a fraction to a percentage because that would require us to know what that fraction looks like with a denominator of 100. So instead, we convert to a decimal first by dividing, and then, or sorry, convert fractions to percentages by, yes, converting the fraction into a decimal by dividing. Then we multiply that decimal by 100 to get to a percentage. All right, if we want to convert decimals to fractions, what we do is we take the digits of that number and we write it over the place value of that last digit. This one's a little bit confusing until you see it in writing. So for example, if we want to convert 0.5 into a fraction, what we do is we take 0.5, the digits that make up 0.5 are a 0 and a 5. So when it's a 0 in front, we just don't write the 0. So I'm just going to write the 5 on top. And when we say to put the number over its place value, what we mean is whatever the place value of the farthest right digit is, that tells us what to make the denominator. So this 5 right here is in the tenths position. So this is the fraction 5 over 10. Or again, I put a 10 on bottom because this 5 is in the tenths position. Then we reduce the fraction, and so this is 1 over 2, which we should recognize from my example up here. I'm going to do another one for you real quick. So if we have a decimal like 0.75, we can turn this into a fraction by putting the digits 7 and 5 over the place value of the farthest right decimal spot, which is this 5 here. This 5 is in the hundreds spot, so I put 100 in my denominator, and then I could reduce 75 over 100 to be 3 out of 4. Okay, but the key there is we put the digits from the decimal over the place value of the farthest right decimal number. So in this case, the 5 is in the hundredth spot, so we put 100 in our denominator. A couple more here. If we want to convert percentages to fractions, then we put the number over 100 and we reduce the fraction. So if you want to turn a percentage into a fraction, we put the number over 100 and then reduce. And we can see that example up here at the beginning. If we want to turn a percentage like 38% into a fraction, we just write the number as the numerator and put 100 as our denominator. But then we would need to simplify that to get a reduced fraction. And our last one, to convert percentages to decimals, all we have to do is divide by 100, which is equivalent to moving the decimal spot 2 places to the left. So for example, if you had 7%, this is equivalent to 0.07 because I moved the decimal place, in this case, 2 spots to the left. And so when I do that, I have to put an extra little 0 right here, which becomes that 0 in front of the 7. All right, so now let's do some examples of converting. If we start with the fraction 3 over 25, and we want to turn this into a decimal, we divide 3 by 25. So now we could, of course, do this by hand and work it out, but in this class, we're going to be using calculators quite a bit anyway, so we should just get used to it. So if we divide 3 over 25, that gives me the fraction 0.12. So I'm going to take 0.12, that is my decimal. Oh, let me fix that handwriting there, 0.12. And then to turn a decimal into a percent, we multiply it by 100. So if I take 0.12 and multiply by 100, I get 12%. In the next row, we are starting with 0.761 as a decimal. If I want to turn that into a fraction, I take the digits 7, 6, and 1, and I write them over the place value, where the 1 right here is in the thousandths spot. So I write it over 1,000. Then we need to check if this can reduce at all, which Desmos calculator also can do for us. So if I take 761 divided by 1,000, if I click the little icons where it's a box over a box next to the answer, so where it says 0.761, if I click the little symbol next to it, it'll reduce the fraction for me, but notice it's the same fraction. So that means this fraction does not reduce. All right, and then to turn 0.761 into a percent, we multiply it by 100. So that'll give us 76.1%, where really multiplying by 100 is just the same as moving the decimal place twice to the right. All right, last one, we need to take a percentage of 104% and turn it into a decimal. So we can move the decimal twice to the left to get 1.04 as our decimal. So just moving the decimal twice to the left, that is the same thing as dividing by 100. And then the way we turn it in to a fraction is we take the original percentage and we write it over 100. So 104 divided by 100. We also could see that that's how we get to the fraction by taking the decimal and the digits 1, 0, and 4 we write on top. And then the 4 is in the hundredths place value, so 100 is my denominator. That fraction is not reduced though, so I can see that that fraction is going to reduce to be 26 over 25, because if I divide top and bottom by 4, it'll simplify nicely. But if that's not something you can do so easy, don't worry, Desmos can simplify fractions for us. 104 divided by 100, if I click the little icon next to the 1.04, it reduces that fraction for me to be 26 over 25. So 104 over 100 is really 26 over 25. All right, so now percent problems. The most important thing to understand is what the words we're going to be looking at mean. So step one is to translate the question into an equation to solve. We're going to see some examples of equations, and you're going to notice that it's very formulaic how we go about solving. Every word in the sentence is going to go directly into an equation word. And so we need to know what those words are going to look like. So first off, the word is translates to equals. So whenever we see something is something else, we'll put an equal sign where that is. is. You guys get it? The word of translates to multiply. Unknown values will get assigned variables. And percentages are always converted to decimals or fractions. So we will never, okay, right here in bold over here, never use the percent without converting. Okay, so whenever we see a percentage like 4%, we will always turn that into 0.04 or 4 over 100. We will never use the percent directly in the problem. All right, so now that we know is means equals, of means multiply, and unknown values become variables, now we can go ahead and actually solve some examples. What we're going to be doing is translating to an equation and then just solving that simple equation that we end up with. So for number one, we have what is 60% of 80? The word what is an unknown. We don't know what it is, so we will call that x. The word is translates to equals. 60% we need to convert to either a decimal or a fraction. Usually we use decimals, but you're more than welcome to use fractions if that's what you prefer. But as a decimal, 60% is 0.6 or 0.60 if you want to write that extra zero on it. The word of means multiply. So I'm going to put a dot there for multiplication. And then 80 is just a number, so we're just going to write 80 as what we multiply by. So now for this first time, I wrote of as a dot to mean multiply, but I'm actually going to change that because I want to point out that although that works, it's kind of hard to read when we look at it. So instead, to represent multiplication, we're going to be using parentheses moving forward. So that of does tell me to multiply, and it's kind of caused me to put the 80 into parentheses. So now to solve this, we don't have to really do anything to solve. We just have to multiply the right side out. We're going to end up with x is equal to 0.60 times 80 gives us 48 as an answer. So it says, what is 60% of 80? We would say that 48 is 60% of 80. Number two, 162 is 18% of what number? So 162 is just a number, so we just copy that down. The word is translates to equals. 18% we need to write as a decimal instead of as a percentage, so that's 0.18. Of tells us to multiply, so I'm going to put some parentheses to represent multiplication. And then we don't know what the number is, so what number, that is going to be our x variable. So now we have a one-step equation. 162 equals 0.18 times x. All we have to do to solve this is divide both sides by 0.18. So if we divide the right by 0.18 and divide the left by 0.18, we're going to get to our answer. On the right side, these factors, or these 0.18s, cancel to just give me the x. And on the left side, 162 over 0.18, we can go ahead and use our calculator for. So 162 divided by 0.18 gives me 900 as a solution. What that tells us is that 162 is 18% of 900. And if we wanted to double check that we were right, we could always do a check step on the side over here where we could check 18% of 900. And if we want to calculate that, oops, sorry, I forgot to write the percent on the 18. Let me fix that. So 18% of 900 means 0.18 times 900. And if we calculated 0.18 times 900, we would get 162. So you can always go back and double check by just plugging these numbers in for where we had the x originally and making sure you get a true statement. Okay, number three, 135 is what percent of 160? So 135 is just a number. We're just going to copy that down. The word is means equals. Then it says what percent of 160. I'm going to skip the what percent for a second and go of 160. Of means multiply. And 160 is just a number, so we're just going to put that number inside. But now the question is, how do we handle what percent? Well, usually when we don't know what something is, we put x in its spot. But in this case, it's not just a number that we're finding, it's a percentage. So instead of putting x, which we will then have to convert to a percent later, we can represent what percent by doing x over 100. So because we don't know what the percentage is, we can go ahead and say that x over 100 represents that actual percentage, where now when we solve for x, x will be the percent. But in the problem here, by dividing by 100, we have already turned it into a form that we can work with. The alternative way to do this would be to just write x here, solve for x, and then at the end convert x into a percentage by multiplying by 100. But I prefer to put x over 100 in right away. That way I know exactly what I'm solving for. At the end, when I get x, x will be the percent. So what percent causes me to write x over 100? I could also write 0.01 times x. That way I'd be turning x into a decimal like we did in these previous two examples. But I prefer to write x over 100 in this case because having a 100 makes it easy that when I want to get rid of that 100, multiplying by 100 all around is not really a hard step because you just move the decimal place when you multiply by it. But sometimes putting the 0.1x there confuses some students. So I prefer the x over 100. All right, now we want to solve. So what we're going to do is simplify both sides here. We have 135 equals, and if I multiply the x over 100 times 160, I'm just going to move that 100 to be 160 over 100, where all I really did was combine the two fractions. The 160 is on top and the 100 is on bottom. I can then reduce that fraction though to just be 16 over 10. So when I multiply 160 by 100, you can see I deleted a 0. See, those zeros went away because 160 over 100 is really just 16 over 10. And we could even reduce that farther. So what I'm going to do is show you both steps. So I'm going to leave it as 160 over 100, but we're going to reduce that all the way down. Because we had 16 over 10, that's really 8 over 5. So 160 over 100 reduces to be 8/5. And then all we have to do to solve is multiply both sides by the reciprocal, which is 5 over 8. So if we multiply both sides by 5 over 8, we're going to end up with x is equal to, and then on the other side, we'll bring out our calculator to multiply. We have 135 multiplied by 5 over 8, which gives me 84.375. So that tells me that 135 is 84.375% of 160. And so the percent we were looking for is that 84.375. So now usually when we get to the end of these problems, we like to clarify that this 84.375 really represents 84.375%. So we have now found the percentage that represents our solution. All right, number 4, we have 2/9% of 2,700 is how much? So we're going to convert 2/9% into a fraction by making it 2 over 9 divided by 100. Okay, we can convert it to a fraction by just writing it over 100. The word of means multiply, so I'm going to put parentheses to represent that multiplication. The number 2,700 is going to go inside of those parentheses. Okay, 2/9% of 2,700 means to multiply by 2,700. The word is means equals, and how much is the amount we don't know, so we'll call that x. So now all we have to do is simplify that left side. We can go ahead and we could do this one by hand pretty easily, to be honest with you, because 2,700 divided by 100 is just 27, and then 2/9 times 27 is just 6. So I know the answer is going to be 6, but we can go ahead and use a calculator. 2/9 divided by 100 multiplied by 2,700 just gives us 6. Just make sure when you're using the calculator that you put the fractions in the correct places, the way you see that I did here. So we would say then that, oops, wrong color there, that 2/9% of 2,700 is equal to 6. All right, now we're going to turn this into a couple word problems. So the head nurse at a hospital asked the staff, how much of a raise would make you feel properly paid? Out of the 119 nurses who responded, 79 said an extra $20 an hour would be enough. What percent of respondents believe that an extra $20 an hour is enough? So we have a few numbers we were given. 119 surveyed, 79 said that $20 is enough, and we're trying to find out what percent of respondents said this. So we want to know, we want to be able to answer the question. 79 that said yes, 79 is what percent of the people surveyed, which is 119. So translating this word problem into problems like we saw above, numbers 1 through 4, 79 out of the 119 said $20 is enough. We want to find out what percent that is. So 79 is what percent of 119? We then turn this into an equation. 79 equals what percent? So x over 100. Oh, I forgot the word of up above. I was about to say the word of means multiply, but I didn't see the word of. So 79 is what percent of 119? So we have 79 equals x over 100 multiplied by 119. All we have to do here to get to our answer is solve for x. So we can go ahead and multiply both sides by 100 over 119 because the 100's in the denominator and the 119's in the numerator. So on both sides, 100 over 119. On the left, the 100 and 119 cancel to just give us our x. Sorry, that's on the right side. And on the left side, we just have to multiply it out. We have 100 over 119 multiplied by 79. And this gives us 66, and we'll round that to be 0.39. So approximately 66.39. So because I rounded, I will change my equal sign there to a wavy approximation symbol. So approximately, or about 66.39% said that an extra $20 an hour is enough. Okay, we have two more in here. A patient's bill was $1,200 before insurance. If the insurance covers 80%, how much does the patient pay? So we have a bill, we have how much the insurance covers, and we want to know how much the patient pays. So first, we need to think about what this question is asking. How much does the patient pay is not the 80% number, because 80% is how much the insurance will pay. Okay, so if, using this 80% here, if insurance pays 80%, then the patient pays the remaining 20%. Okay? Because altogether, we have to pay 100% of the bill. So if insurance pays 80%, then the patient is going to have to pay 20%. So we are now trying to answer the question, what is 20% of $1,200? All right, so if we translate that equation or translate that sentence into an equation, the word what is x, is means equals, 20% we can write as 0.20. The word of means multiply, so I'll put parentheses, and we have the number 1,200 there. So we need to find out what is 0.2 times 1,200. So we could multiply it by hand, but we have a calculator, so why not? 0.2 times 1,200 is 240. So we would say that x equals 240. And so that means that the patient pays $240. All right, so the important thing there was to realize the patient is not paying 80%. The insurance is paying that 80%, and the patient is paying the remaining 20%. All right, one more. A hospital increases its nurse staff by 15%. If there were originally 120 nurses, how many are there after the increase? So there's two ways we could do this. We could find out what is 15% of 120 and then add that to the 120 nurses we already had. Or we can find out what is 115% of 120. Because if we increase by 15%, okay, 100% is how much we start with. So if we add on an additional 15%, we are now at 115%. So instead of doing two problems where we have to find 15% and add it to the original, we can just find 115% of 120. So what we want to know is what is 115% of 120? So this is going to translate to x equals 1.15, because I moved the decimal place on the 115 twice to the left to get 1.15. 1.15 multiplied by 1200. So then we can go ahead and work this out. 1.15 times 1200 gives me 1000. Oh, not 1200, sorry, 120. So 1.15 times 120 gives me 138 nurses. So 1.15 times 120 gives me x equals 138. So how many are there after the increase? There's now 138 nurses at this hospital. The key to percentages is all about turning the words into an equation. If you can do that, the equations themselves are actually quite simple, but you have to make sure you know that the word is means equals and the word of means multiply. Beyond that, as long as you're turning percents into either decimals or fractions, you should be okay. All right, see you guys in the next one.